Yeah. Okay, so number one, when I open this file up, both the lid and the base, or I'm sorry, yeah, this you did the lid and then the base in the same file. We've got to separate them. So I'm going to immediately go and save as. Actually, I'm just going to delete this.
Oh, I did it. Oh no.
You can delete it from the browser. So I'm just going to show you this part. Okay, you got to do them separately. Okay, so this is the design tab. Now you go to manufacture, and that has all the CAM tools, computer aided manufacturing tools. Hey guys, we're recording. Can you guys just give us a minute? Kev, we're recording. Can you just give us a minute? Thank you. So you can see in here, these are the same tools from my video. In the portfolio guide, I gave you CAM 1 and CAM 2 videos. These are the same tools, same process. So I'm just going to use adaptive clearing. This X, Y, and Z has to be relocated. You probably want to put the units in inch mode too. So up here, you can just go back to inches. Okay. Now I'm going to go to the setup process. I'm going to do a new setup, and then choose the corner. This is my 0, 0, 0 location. X, Y, Z zeros. It's where the X is on the long portion of the container, Y is on the short, and then Z is up, pointing up. Okay, that you have to position it correctly, so the code generates from that location. So when we set it into the machine, it all corresponds. So I'm going to select, I'm going to look at the stock. I noticed that his X is 5.08, depth is 3.08, and height is 1.04. So this is 1.5 inches tall. Okay, you cannot go beyond 1.2 inches according to the portfolio guide I gave you. X distance, that's too long. You cannot go longer than 4.25, 4.25. So I'm going to tell you right now, this isn't going to work. Okay, because you didn't follow the geometric constraints needed to, because this, I give you this block. This is 4.25 by 3.25 by 1.5 high. You have to subtract the material from this to produce your part. And if your stock, if you designed it too big, right, it's not, you can't do that. But I'm going to keep going just to show you some basic processes. So I'm going to select OK. We've got our XYZ set up. Now I'm going to, you can do pocket just like I did in the CAM videos, face. I'm going to try this new adaptive clearing process. I'm going to set up my tools here, select. I'm going to go to this little plus sign, and I'm going to set up my flat end mill. And I'm going to select all the same settings compared to the portfolio guide. Okay, so if you go back to my announcements and go to portfolio guide or the container project, and then click on portfolio guide, we're just going to reference all the tools that we have access to in the lab, and they are right starting on slide number 21. So there's the face mill tool one. We're going to use the 1/2 inch mill and set that up tool two. So we just going to, I'm going to make sure all these settings correspond to the setup in Fusion. So I'm just going to toggle back. All right, so flat end mill, units in inches, the number of flutes. What's it say in here? You guys see it? There's 2 flutes, there's 2 cutters, 1, 2. I don't think it's mentioned anywhere else, is it? I don't see it. So 2, we'll use HSS steel, diameter 1/2 inch. that changes overall length. What's the overall length? 2.5. See from here to here? 2.5. So we're just programming this right now. Length below holder. So that's this position, right? The body length, 1.675. Shoulder length, and it tells you what that is. So you just match that up with the portfolio guide. The shoulder length, 1.5, thank you. And then the flute length is right here, from here to here, 1 inch. So we're just setting exactly the tooling that we're gonna use up. And then we'll look at the cutting data. So these are like the speeds and feeds. So we recommended 40 inches per minute last time. So we're gonna maintain that, 40 inches per minute, 4,000 spindle speed. So we'll back this down to 4,000 RPMs. Surface speed is a function, so you don't have to calculate that because it's already in the library. Ramp spindle speed, that's fine, we'll leave that. So we're just gonna match this data, recommended data up. Beat per, these are all functions, so you don't have to change that, you don't have to change that. Plunge feed, plunge should be half the feed rate, so we could bring that up to 20 inches per minute. Oops. Oh yeah, and ramp feed can be the same thing. Yeah, that's fine. Plunge 20. Feed per revolution, that's a function. And then coolant off, disabled. Okay. We're gonna set tool number 2 up. So in our machine, it's positioned in the automatic tool changer as tool 2. So in the code, it'll be like referencing T2. There should be no offsets, length offset. I'm gonna set that to 0. Let's just read what that says. The index of the tool length offset for parameters normally set when you use tools with multiple tips. Okay. So we're gonna set it at 0 for now. And then that's it. So accept that. Our tool's set up. We're gonna select that tool. Now you can go and set up all your tools. We got this tool, we got an 1/8 inch flat end mill, we got a 1/4 inch flat end mill, we got an 1/8 inch ball, which cuts curved surfaces. We've got a tapered mill, which is more like an engraving for your top. So depending on what cut procedures, you would set those tools up and choose your CAM process. And let's see if this lets me choose the whole model and just run it on the whole part. Let's see. I want it to cut like the bottom, I want it to cut the profile. So all this detail in here. And then we can go back and change these settings later. I don't want any stock to leave, take that off. We might have to go back in here and look at these later. There's a lot of variables to consider when programming the machining process. Let's just see what happens. So I processed it, it's processing over here. And I don't think it did what I wanted to do. So we can simulate this now. Anybody see where simulate is? Right here. No. I want to simulate this. I'm going to right click. It used to be right here, simulate. And then you can see how what is done. Now that's not what I wanted. So obviously I need to go back, exit out of simulation. I'm gonna delete that process. I don't want that. And we're gonna just go as recommended. So I'm gonna do a pocket, select my tool, select the tool I set up, And let's pocket that surface area. Take stock to leave off. All right, that's what I wanted right there. So I can right click on that process, or I can right click on the setup, and if I had multiple processes, I could now simulate the whole thing. So I only did one, so but we just programmed the machine to do that. So you want to get everything cut out the way you have it designed is the object using those CAM tools. If you get it all done, you literally just select the setup, you go to post process. Well, you can actually do a couple things. You can create an NC program. Yeah, and then this is where you select your post processors. So we have the Haas. We have a Haas machine. And all these machines in here. This is like all the machines in the world you can choose. But we have a Haas, so let's just search Haas. Yeah, here it is. Ours is a Haas TM1P, but I think you can run it off of. Yeah, there's our Haas TM1P. And then when you let's just give it a unique number.
Good afternoon.
Hello.
May I get Terrence Mackey for dismissal, please?
He's on his way.
Thank you.
Oh, I needed to output it to a. Output folder needs to be like a flash drive, or I mean, I can put mine in my downloads folder for now. You can also have all these presets in here too. You can look at those later. Haas TM1P. Anyway, the point is, this is a lot further than I was going to take you, but the point is you can generate a computer file that the machine will run from this point. So that's basically what I wanted to show you. I just having some technical difficulty with this post processor. Oh, there it is, Haas TM1P. Yeah. It should be posting. There we go. It's just posted, so I can view my NC code. And once in my downloads folder, but you can view it from here. So see all this code, G&M code? That's what the machine is going to read to run that pocket. Is that a good quick overview?